Hi everyone! Welcome to the PVS Studio channel. Today, you'll learn about top 5 most common myths about static analysis. You may ask, who are you guys? Well, we're the ones who develop a static analyzer. So we get to hear a lot of strange things on the tool. Okay, enough words. Let's do it. In 5th place, we have the myth that you don't need to run static analysis regularly. Quite a lot of people think so. I don't know why, but that's the way it is. To dispel this myth, let's start with why this type of tool even exists. Of course, first and foremost, it searches for errors. To be more specific, it detects failing places. And here comes the programmer who looks at the report and edits the code if necessary. Well, now let's imagine that you have a typo in your code, just like this piece of code in CMake project. By the way, the project is well known among C++ and other developers. See the typo? If you want to find it yourself, just pause the video. So the analyzer is not happy about the MenchW32 macro here. The fact is that the author forgot to add the second underscore at the end. So with this code, the condition in the macro will never be met. Why am I saying this? One day, this place will trigger, and something tells me that finding this problem will not be the most trivial task. However, after some hours of persistent debugging, everything will be fixed. But what if we run the analyzer after each build to check modified files? Isn't it more sufficient? Well, you can argue here that this piece was found a long time after it had been written. Yeah, you're right. The example is not perfect. So this time, let's imagine the hypothetical situation. The clatter of mechanical keyboards wafts through the persistent smell of coffee and dissolves into the hum of open space. Jack is a typical programmer. It's been 2 hours since he started fighting with a kernel crash, though the code seemed absolutely correct at first. After a smoke break, Jack heroically solves the problem and runs the analyzer before a review. You may have a question here. Why wait? Why not to run the analyzer before? After fixing all the problems in the code, the analyzer doesn't have much to report about. For the most part, its task is to find problem errors before debugging. What about dynamic analysis? Is it better than static? This is our next myth. Which one is better? Many compare these two types of analysis as they overlap in some directions, such as memory leaks. The only problem is that they review code from different perspectives. Dynamic analysis follows the program during the execution. It analyzes all calls, what happens to memory, and things like that. Static analysis literally digs into the source code, runs through the lines, and looks for potentially problematic places. For example, there is no such thing as unreachable code for a dynamic analyzer. The code has to be covered with tests for the analyzer to review it. A static analyzer doesn't care about tests. It reads the code. What does it mean? Is static analysis even better than dynamic? Nope. They complement each other and intersect in some cases. Actually, we shouldn't compare them at all. They specialize at different things. The myth static analysis is expensive opens the top 3. So some say the price is too high. Well, it depends. Let's start with the question, who actually needs it? Single developers rarely develop something really large and complex. As for small projects, a professional static analyzer may be redundant. And no, it's not just about less code. It's also about less human factor. Remember I told you earlier that it's better to use static analysis right during the development process? It is the same case. The point is that a critical bug is likely to trigger somewhere. It's going to be fine if it happens while testing and the problem code will be revealed right away. But what if it's found somewhere at release? That is why the fewer bugs get to the release, the better. It's all because the cost of the error at this stage is quite high. But static analysis is not a silver bullet, so it won't be able to find all errors. Neither will get all likes, but how about this? What if the analyzer finds critical problem before the code has left a developer's computer? You'll definitely make back the money you spent to buy the analyzer. So what's the verdict? Yes, static analysis is expensive if you use it for a small project where the error costs little money. But large projects will get a lot more profit than they will spend on license. So expensive is a relative concept. Okay, let's move on. This part is about integration. So let's talk about the myth it's difficult to integrate the analyzer. Well, it depends where to integrate. If you are working in an IDE, it's usually enough to install a plugin and enter the license. Still, there may be discrepancies. For example, Coverity is installed directly from the plugin after entering the license. This is due to the fact that Coverity is very closed. If you're not a user, then almost nothing of the documentation is available to you. In our case, you can install both the analyzer and plugins for needed IDEs. Other analyzers work about the same way. In short, if you use an IDE, you will not have any problems. But things are different with a variety of console utilities and CIs. Here, each analyzer has its own approach. Either way, you will need to read manuals a bit. Anyway, support service is usually available and ready to help. The myth static analysis is very noisy proudly takes the first place. Yeah, that's true. Well, thanks for watching. Okay, wait. For the most part, this is still not a myth. Yes, any static analyzer issues false positive warnings, and without this, it simply cannot exist. Here's why. Any potential error that static analyzer encounters in the code has two important characteristics: level of certainty and criticality. Of course, you may say that you could only show the most reliable responses. Well, that's what we do. If the level of criticality is not high enough, we don't give a message. But the analyzer is still not a programmer. It doesn't know what the code is about. It only has rules inside, so it reviews code according to them. So what is correct in the analyzer's opinion may not be so. Therefore, it shouts about anything reliable that it sees on the way. Okay, what about certainty? We divide all warnings into 3 levels. Low, not critical enough or with insufficient certainty. Medium, medium certainty. High, with a high degree of criticality or certainty. So you can use these filters to choose the optimal group of warnings for yourself. What did I mean by that? Yes, static analysis is noisy, that's a given. However, not all warnings reach the user, but only fairly reliable ones, which in turn are divided into groups according to certainty. Well, luckily we have various flexible options to help you configure the output. In the end, all this noise will be eliminated by filters and settings. Today we touched upon the most common myth that we hear about static analysis. If you have any other myth ideas, don't hesitate to write them in comments. If we have enough of them, we'll make the second part. Thanks for watching. Don't forget to subscribe. See ya!